My dear students, I need you to understand one thing. Ne? There's a difference between an expression and an equation. So with an expression, you're just given a mathematical problem that doesn't involve an equal sign. Whereas with an equation, you're going to have a mathematical problem whereby it's a comparison of the right-hand side being equals to the left-hand side or the other way around. But there should be an equation, there should be an equal sign presented on an equation. So um, whenever you are dealing with a question, it's very much advisable and wise for you to read exactly what is expected of you, because students were just going to be all over messing up some good marks which they could have accumulated because of not understanding the basics of what they are dealing with. So learn to differentiate between an equation and an expression. So for our question today, as presented here, we have to simplify the following, of which with expression, you get to simplify the expression. But with equations, you probably will have to solve for unknown variables given on that equation. So here on this question now, we are presented with expressions. So we have to simplify the following expressions. And as presented here, you will have different types of expressions to simplify, which you have to approach them in different forms. So now for practice purposes, let's go through with this one. We're going to do 1.3.1. Let's go. So here I have to simplify this expression. As you can see, there is no equal sign involved, such that I just have to show steps by steps by steps by steps, going down to simplify it. Some students would approach this by saying this expression is equals to, and then they present what would be the next step to that. There is nothing wrong with that. But to be on the safer side, rather you stop involving an equal sign if you want, and just go ahead and simplify this step by step. It would be very much understandable. So here we have to use the so-called FOILs: first term, outer term, inner term, and last term. Meaning, what I have to do is I will have to multiply this by this, and then I'll multiply this by that, and then I'll multiply this by this, and then I'll come and multiply this by that, and multiply this by this, and multiply this by that. And then after simplifying the whole thing, the answer will just be out there without even forcing anything. So let's go. If I multiply x by x squared, I would have x cubed. If I multiply x by x, I will have plus x squared. And then I multiply x by 1, and then I have plus x. So I'm done with this one because I multiplied it with 1, 2, 3. And then I come to minus 1. Minus 1 times x squared will give me minus x squared. Minus 1 times x will give me minus x. And minus 1 times 1 will give me minus 1. This is what I have. The whole point is I want to simplify this to the simplest form I can get. Now, if you see, I have x cubed. It doesn't have any like term relating to it. But then looking at the other terms, I have x squared here, and I also have x squared here. So x squared minus x squared is 0. Somehow you can think of it as they canceling each other. And also I have plus x minus x again. Plus x minus x, I like terms. It's the same as me saying x minus x. You can see they also cancels each other. And then I'm left with minus 1 as it is. So the simplest form of the given expression is x cubed minus 1. I didn't put any equal sign. But like I say, even though it was presented without an equal sign, there wouldn't be anything wrong if I say this is equals to, this is equals to. That is me comparing the expression that was given with what I'm getting. But also, if you don't put equal signs to it, you would still earn your full marks because you have done nothing wrong. It is an expression. Technically, it's not supposed to have an equal sign. So that's the answer for 1.3.1. Now, looking at 3.1.2, I still have to simplify the expression because it doesn't have an equal sign again, and it is in a form of fractions. All I need to do, you know that when we are solving fractions, we're going to take the lowest common denominator and then we work it out like that. But with this one, you can tell that the denominators, they look a bit complicated, such that I can first simplify the denominators and then I solve the whole thing. Let me show you how it's done. So from the given equation, I'm happy with the top part of the numerators mostly because they are in their simplest forms. This one, I can simplify it further. This one, there's nothing much I can do to it. But also this one, I can simplify it further because I can somehow see that I have a common factor of 2. If I simplify this, for the first denominator, I would just have to factorize. And to factorize this, if you don't know how to factorize, you can look for a video. We are teaching how to factorize. But otherwise, to get factors of this, you ask yourself, what would you get for x squared? So to get x squared, you multiply x by x. And what would be the factors of 6 such that I must also have a middle term of minus x? So 3 and 2, that gives me 6, and 3 minus 2, that gives me 1. But because this one is a negative sign, I would have to give the bigger one a negative sign, and then this one would be a positive sign. That's the simplest form like that. Minus 3 over x minus 3 plus 2 over, here I have a common factor of 2. If I take out the common factor of 2, I would be left with x plus 2 from what I have inside the brackets. But now, the nice thing also that I pick up here is that these 2 can be divisible by these 2, such that this and this can cancel, and then I'll be left with the expression of the form x plus 7 all over x plus 2, x minus 3, minus 3 over x minus 3, plus 1 over x plus 2. So from here, it would be easy for me to take out the common denominator because you can see here I have x plus 2, here I have x plus 2, here I have x minus 3, here I have x minus 3, such that I would say my lowest common denominator is just going to be x plus 2 and x minus 3 because it accommodates everything I have in the denominators. And then now I simplify the whole thing. This divided by the whole thing here, it's going to be 1 because this the whole thing dividing by the whole thing here, it's going to be 1. And then 1 times the numerator, it's going to be x plus 7. And then moving on to the next one, x minus 3 divided by x plus 3, x minus 3. Obviously, it's going to cancel x minus 3 and x minus 3. I'm only going to be left with x plus 2. Therefore, this is going to be minus, if I multiply it with the numerator, so I'm just going to multiply x plus 2 with the numerator, and then I would have x, no. I would have 3 into x plus 2. And then this one goes how many times to this one? It's going to cancel the x plus 2 and x plus 2. I'm only going to be left with x minus 3. Therefore, it's going to be plus x minus 3. This is how you go. And then the next thing to simplify this further, I will then, the denominator is x plus 2, x minus 3. This one, I just write it as it is x plus 7. Therefore, multiplying again the FOIL, I'm going to multiply this here, and then I'm going to multiply this there again. Minus 3 times x will give me minus 3x. Minus 3 times positive 2 will give me minus 6. Therefore, here, I only have 1 here, so I'm just going to take it as it is. So it's going to be plus x minus 3. That's what I have. Now, simplifying this one further, again, I'm going to write the denominator as it is. So we still have x plus 2, x minus 3. Therefore, look at this. The like terms, I have x minus 3x plus x. So x plus x is the positive. It will give me 2x. 2x minus 3x will just going to give me minus x. And looking at the other one also, I have minus 6 minus 3. plus 7. So 7 minus 6 is going to be 1. 1 minus 3 will give me minus 2. So this is what I have now. I have minus x minus 2 over x plus 2 into x minus 3. To create space, now let me just rewrite this here. So I have minus x minus 2 all over x plus 2, x minus 3. As you can see, this one here, I want to have a proper form of this, and it consists of negative signs. So I can take out -1 as a common factor here. If I take out -1, it means I'll be left with x plus 2 inside there over x plus 2 into x minus 3. Now, you can tell that the x plus 2, obviously, this and that will cancel because they are common terms. Then my final answer of the simplest form would be -1 over x minus 3. That would be my final answer for that. Let me just write this properly. So this is the simplest form. So from here, I can't simplify it further. This is the simplest form I could get from the given question. Now, lastly, for 1.3.3, we again have to simplify the expression, but then now the expression is given in the form of exponents or in exponential form. This one we may need. Now, for this one, if we have to simplify this expression, we have to look at how we can simplify each and every base to its prime factor or its simplest form. 4 can be written as 2 squared is to x plus 1 multiplied by 9 can be written as 3 squared into x all over. Writing 6 to its prime factors, it's going to be 3 times 2 into 2x minus 1. That's the first step. Now, the next thing, I'm going to multiply the exponents because we have an exponential rule that says we can multiply this with what we have inside. We can multiply this with what we have inside. And also here, we can multiply this with what we have here and what we have here because any number is to the exponent 1. So here we would have 2 Here we would have 2 to the exponent 2x plus 2 because 2 times x, 2 times 1. Multiply by 3 to the exponent 2x all over 3 to the exponent 2x minus 1 into 2 to the exponent 2x minus 1 because I've broken it down like that. And then the next thing, I'm going to do my separation. If I do separation here, I would have 2 to the exponent 2x times 2 squared multiplied by 3 to the exponent 2x. This one is all over. Let me just create space there. This one, if I create space there, this one is going to be all over. This one is going to be all over 3 to the exponent 2x times 3 to the exponent -1 multiplied by 2 to the exponent 2x times 2 to the exponent -1. And then from here, you can see we have like terms because it's multiplication throughout. Since we have like terms, we can see that the 3 to the exponent 2x cancels the 3 to the exponent 2x, and also the 2 to the exponent 2x cancels the 2 to the exponent 2x, meaning we are left with this type of an expression. We're left with 2 squared over 3 to the exponent -1 multiplied by 2 to the exponent -1. And applying the rules of exponents again, we can tell that the top part, we can simplify it further because this and this, they have the same base. Using the rules of exponents, this is the same as 2 into 2 minus -1 for the one with the same base, all over 3 to the exponent -1, like that, such that But also we know that 3 to the exponent minus 1 is the same as 1 over 3, because it's another rule of exponents. 3 to the exponent negative 1 is the same as 1 over 3. I'm talking about this one now. So I can simplify this further by saying here I would have 2 to the exponent of 2 minus 1. This is going to give me 2 to the exponent 3 divided by 1 over 3, because 3 to the exponent minus 1 is the same as minus 3 over 1. And I'm avoiding to have a fraction dividing a fraction like that. Hence, I just write it in this expression because it's the same. And having a division sign, this is the same as 2 to the exponent 3 times 3 over 1. Therefore, you can simplify this further because we know that 2 to the exponent 3 is the same as 8 times 3. This is going to give us 24 as an answer. So our answer for 1.3.3 is 24. So students need to understand that there's a difference between an expression and an equation. I'm Mr. Maimane. This is Simplified RSA, and we are the guys who makes it looks easy. Don't forget to subscribe to our YouTube channel, follow us in all our social media platforms, and if you need private lessons, do feel free to contact us. Either send us a WhatsApp on this number or an email. I'm done for today.